The immune system protects against pathogens using barriers, which can be non-specific or specific. The lines of defense. We'll start off with the first line of defense. The first line includes your skin, cilia in your body, antimicrobial proteins or lysosomes, which are in your saliva, your mucus, your tears. Their job is to break down walls of the bacteria, your gastric juice, and then symbiotic bacteria. For the first line of defense, your ears, eyes, and nose play many different roles. Your eyes do their job by blinking, which wipes tears away from the eyes. Your ears have hairs and wax, which trap pathogens in the passageway. Your nose has nasal passages, which are lined with mucus, which secretes, and hairs that trap pathogens. Next is the second line of defense, which is also nonspecific. It includes phagocytes, or white blood cells, which engulf pathogens by using phagocytosis. Secondly, it includes interferons, which are proteins that are produced by infected cells that will stimulate neighboring cells to produce proteins that'll end up defending against infecting viruses, or they'll call some white blood cells over. The inflammatory response is third. You can have pain or swelling at the infection site. Our diagram for the second line of defense is just a swollen ankle, which can be caused by the mast cells that have burst in the area and released histamine. Histamine causes the nearby blood vessels in the ankle to dilate, which bring more blood to the infection site. And lastly, phagocytes are attracted to that area and release a chemical signal that'll bring more blood to the area. Oh my gosh, there, are you okay?
Yes.
Your ankle is so swollen. Ah! Up until now, the immune response that we've been seeing have just been general and not specific to the pathogen that has invaded the body. But in the third line of defense, we get a little more specific. MHC helps to distinguish between self cells and foreign cells in order to produce the correct antibody. Antibodies help remove foreign antigens. The diagram for our third line of defense is a picture of a bone, and inside you can see the bone marrow. B cells, which produce our antibodies, are made and matured in our bone marrow. B cells respond to antigens, produce antibodies, which are proteins, to fight against the antigen. There are 5 different classes of antibodies. Memory B cells. Memory B cells stay even after you get an infection to make your immune ready for future attacks from the same strain of infection.
The humoral response involves B cells that recognize antigens or pathogens that are circulating in the lymph or blood. The response follows this chain of events. First, the antigens bind to the B cells. Second, helper T cells can stimulate B cells. In most cases, both an antigen and a co-stimulator are required to activate a B cell and initiate B cells. Third, B cells produce plasma cells. The plasma cells bear antibodies with identical antigen with specifically antigen receptors of the activated B cells. The antibodies are released and circulated through the body, binding to antigens. Fourth, B cells produce memory cells. Memory cells provide future immunity. The cell-mediated response involves mostly T cells and responds to any cell that displays MHC markers, including cells invaded by pathogens, tumor cells, or transplanted cells. The following chain of events describes this immune response. First, self cells or APCs displaying foreign antigens bind to T cells. Interleukins secreted by APCs or helper T cells can stimulate activation of T cells. Third, if MHC and indigenous antigens are displayed on the plasma membrane, T cells produce cytotoxic T cells. Cytotoxic T cells destroys cells displaying the antigens.
T cells originate in the bone marrow, but they mature in the thymus, which is a gland. Cytotoxic T cells, killer T cells, and our helper T cells activate inactive microbes, which stimulate B cell production. They in turn stimulate psychotic T cells. When an antigen binds to a T or a B cell, they proliferate, which is called colonal selection. Since only cells, wait, I don't want to read that, just cut it off. When an antigen binds to a T or a B cell, they increase rapidly in numbers or multiply, which is referred to as colonal selection, since the only cells that match the antigen will be cloned. Vaccines help to develop memory B cells, which fight off viruses by producing antibodies.
There are two types of immune system disorders that we talked about. First, type 1 diabetes. In this type of diabetes, the immune system attacks the cells in the pancreas that make insulin. Insulin removes sugar from the blood to use as energy. And the second immune system disorder is rheumatoid arthritis. This type of arthritis causes swelling and deformities of the joints. An autoantibody called rheumatoid factor is in the blood of some people with rheumatoid arthritis.
Immune system disorders are examples of your body using its 3 lines of defense incorrectly and not helping us.